I hope you are able to view the screen, dear
Yes,
Bhumika.
sir. Yes,
Okay,
sir.
great. So, what we are going to discuss today is on factorization. And to understand factorization, first we need to have a very clear understanding about polynomials. Okay, so you know um, the term polynomial, here there is a word is called poly. Poly means what? Many. Correct, no? So,
Yes,
that is when we have an expression, okay, um, like I'm just going to write an expression a0 into x power n, a0 into x power n plus a1 into x power n minus 1 plus a2 x power n minus 2, and in that way it will continue. So last but one term should be a n minus 1 into x plus an. So this is a polynomial. Okay. In this polynomial, what is there? You see this a0, a1, a2, an minus 1, an. All these are real numbers. Okay. So what is a0? A0 is nothing but coefficient of x power n. What is a1? A1 is coefficient of x power n minus 1. What is a2? A2 is coefficient of x power n minus 2. And in that way, you will find the coefficient of x is an minus 1, and finally the constant term an. Correct or not? Got it?
yes, sir.
Okay. Now, so all these are real numbers, by the way, that a0, a1, a2. In that way, you go to an. These are all belongs to the set of real numbers. Okay. N, what is n? N is a non-negative integer. Okay, what is n? As we discussed, that n is a non-negative integer. Correct? And what is x? You know, x is also a real number. So this is called a polynomial equation, polynomial expression. Sorry, it is known as a polynomial expression, and we can define this as fx. Correct? Clear or not clear?
Yes, sir.
You recall that when we discussed about that quadratic equation. Okay, so what we discussed in that class? We discussed something like that ax square plus bx plus c equal to 0. Correct or not?
Yes, sir.
So this is called an equation. The moment equal to 0, that is an equation. But the moment we just remove that equation part, equal part, that is nothing but an polynomial expression. Correct or not?
Yes, sir.
So this is a polynomial expression. And we can define this polynomial expression. Suppose if we define this as fx, then for different values of x, we will get different values of that expression. Correct or not?
Yes,
Correct. Now, if we write something like this, ax plus b, okay. So this is what? This is a polynomial equation of degree 1. Polynomial expression of degree 1. Why degree 1? Because the power of x here is 1. Correct? No? And
yes,
it is known as a linear polynomial. Linear. Okay, not linear polynomial. We can uh, we can say this is a linear expression. Clear or not clear? Absolutely clear?
Yes, sir.
Okay. And what is here A and B? A and B are a real number. X is also a real number. Now, if we get something like this, ax square plus bx plus c, that is known as polynomial expression of degree 2. Polynomial expression of degree 2. When it is degree 2, that is known as quadratic. Correct or not?
Yes, sir.
Quadratic expression. Similarly, if you get something like this ax cube plus bx square plus cx plus d, that is known as cubic expression. Correct or not?
Yes, sir.
Cubic expression. If you get something like that ax power 4 plus bx cube plus cx square plus dx plus e, that is known as y quadratic expression. Clear or not clear? Now here are some
Yes.
restrictions. Okay, that if you look into that ax plus b, here a and b obviously belongs to real number, and a cannot be equal to 0. Why? Because the moment a is equal to 0, what will get? You will end up with b, which is a constant expression. It no longer become a linear expression. Correct or not? Clear? Got my point now? Similarly,
Yes, sir.
in this case, if you look into this second case, that here a, b, c belongs to real number and a is not equal to 0. Because the moment in the expression ax square plus bx plus c, a is equal to 0, the expression reduces to bx plus c, which is no longer a quadratic expression, it becomes a linear expression. Correct or not?
Yes, sir.
Okay. Similarly, if you find that here a, b, c, d, here in this case belongs to the real number and a is not equal to 0. Because the moment a is equal to 0, this cubic expression reduces to a quadratic expression. And in quadratic, so then it is no longer become a cubic expression, correct or not? And
Yes,
finally,
sir.
if you look into this case, the fourth one, here also a, b, c, d, e, these all belongs to real number and a is not equal to 0. Bhumika, so I just wanted to have you a very clear, idea about all this, linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, then so that we can have a clear understanding about the polynomial equation. Whatever we have discussed so far is a polynomial expression. Got it, no? Expression
Yes,
means what? We have a specific value. Let me give an example. Okay. So by the way, this was, the first one is a linear polynomial expression or linear polynomial or linear expression or use actually interchangeably. Then second one was a quadratic one, third one is a cubic one, and fourth one is a biquadratic one. After that, you no need to go. Till that is fine. Now, what happened? Suppose we get a polynomial, expression. What is a polynomial expression? Suppose we have a polynomial expression fx equal to 2x cube plus 4x square minus x plus 11. Fine. It is a polynomial, expression, and that expression is actually denoted by fx. Correct or not? Now, what is x? Obviously x belongs to real number. Correct or not? Now what is
Yes,
2?
sir.
You know what is 2 here? 2 is the coefficient of x cube. What is 4? 4 is coefficient of x square. What is -1? Here nothing is there means -1. Na? Nothing is there means
Yes, sir.
-1. What is -1 is coefficient of x. And what is 11? It is a constant term. Now, as x belongs to real number, for any value of x, we can find the value of the expression. Suppose I want to find the value of the expression for x equal to 1. So then what we'll get? We'll get 2 into 1 cube plus 4 into 1 square minus 1 into 1 plus 11. Here it is 1 into 1, but it is plus 11, correct? No? So what we'll get? We'll get 2 plus 4 minus 1 plus 11. Correct or not?
Yes, sir.
That becomes 16. So what is the value of the expression? The value of the polynomial expression at x equal to 1 is 16. So that is, again I repeat, this is called polynomial expression. Okay. The moment we say fx equal to 0, that becomes a polynomial equation. Correct or not?
Yes, sir.
So what is a polynomial, equation? For example, we get fx, another polynomial expression, fx equal to, 2, fx equal to, x cube plus x square, x cube plus x square minus x minus 1. Suppose. Correct, no? The moment we write fx equal to 0, so this is a polynomial expression. I write once more. This is a polynomial expression. Correct? And the moment we write fx equal to 0, correct? Fx equal to 0 means what? X cube plus x square minus x minus 1 equal to 0. And
Yes.
that actually becomes a polynomial equation. Correct or not? It is
Yes,
also
sir.
known as zeros of a polynomial. Correct, no? Fine. Now, the moment fx equal to this, that x cube plus x square minus x minus 1, in this polynomial, what we are doing, we are finding the value of f1. Correct, no? The moment we start finding the value of f1, can you please tell me, Bhumika, what is the value of f1?
0.
Very good. Appreciate. Very well said. It is actually 0. Very well said. So, as you see that as the value of f1 is equal to 0, okay, so what we can say? From here we can say few things. One is a 0 of the polynomial fx. 1 is a root of the equation fx equal to 0. 1 is a root of the equation fx equal to 0. Okay. Or we can say from here another thing, or we can say that x minus 1 is a factor of fx, that is x cube plus x square minus x minus 1. Got it, no? Or we can say 1 is a 0 of the polynomial fx. So from here what we can say, 1 is a 0 of the polynomial fx. Clear or not clear? So what are the things we are concluding?
Yes.
That if f1 equal to 0, when fx equal to x cube plus x square minus x minus 1, when we see that fx equal to x cube plus x square minus x minus 1, and for x equal to 1, you know what we get? We get f1 equal to 0, correct?
Yes. Yes, sir.
But from that, result that f1 equal to 0, we can conclude three things. First one is that 1 is a root of the equation fx equal to 0. Second one we can say is that x minus 1 is a factor of fx, which we are going to discuss in details. And the third one is that 1 is a 0 of the polynomial fx. Correct or not?
Yes.
Absolutely clear?
Yes,
So
sir.
now we are mainly focusing on the factorization part, because that's what we are going to, discuss in details. Correct or not? So then, here what we are going to discuss is called the division algorithm. So first what we are going to discuss is that division algorithm. Division algorithm. What the division algorithm is saying? Dividend equal to divisor into quotient plus remainder. That we all know, correct or not? So dividend equal to divisor into quotient plus remainder. That we all are aware of, correct or not?
Yes, sir.
So now we can apply, the same thing. We can apply the same concept in polynomial also, correct or not? Okay, these division algorithm we know from, since our learning of that arithmetic operation, right? Clear or not clear?
Yes,
So
sir.
dividend equal to divisor into quotient plus remainder. Suppose we are going to apply the same thing for the polynomial. Suppose the polynomial fx is divided by the polynomial phi x. So what we are going to write? Let the polynomial fx when divided by the polynomial phi x, when divided by the polynomial phi x, okay, gives quotient psi x and remainder rx. Okay, gives quotient. What is the quotient we are getting? Quotient we are getting psi x and remainder Rx. Then if we write this thing, this one dividend equal to divisor into quotient plus remainder, what we are going to get it? We are going to get it because fx equal to phi x into psi x, correct or not? Phi x into psi x plus Rx. Clear or not clear?
Yes, sir.
So fx equal to phi x into psi x plus Rx. So now, suppose we are dividing a polynomial fx by x minus alpha. Correct, no? We are dividing a polynomial fx by x minus alpha. Then what we are going to write then? We are going to write fx should be equal to, so what is phi x in this case? The phi x in this case is x minus alpha, correct or not?
Yes, sir.
Clear. So what we are going to write here in this case, that fx equal to, so when fx is divided by x minus alpha, so when fx is divided by x minus alpha, what we are going to get? Fx equal to x minus alpha into psi x, that is the quotient, correct or not? Plus Rx, that is the remainder. Clear or not clear?
Yes, sir.
So that is, that we get from the division algorithm. Now from this division algorithm, we come up another concept that is called the remainder theorem. Okay. So what is the remainder theorem tells? That is a very important one. Okay. And we are going to discuss this remainder theorem now. It is pretty simple, but very important. So what remainder theorem tells that if a polynomial fx, if the polynomial fx is divided by x minus alpha, then the remainder r is nothing but the value of the polynomial expression at x equal to alpha, that is f alpha. Are you getting my point? We can establish that. Okay. So if the polynomial, so let me write it down first. If the polynomial fx is divided by x minus alpha, the remainder is f alpha. Correct or not? That is the value of fx, that is the value of fx at x equal to alpha. So how it is obtained? Means from, are you getting my point what I'm talking about? Bhumika, absolutely clear? We'll take some examples, then it will be much more clear. So from the remainder theorem, what you can say, sorry, from the division algorithm, what we can say? We can say fx equal to x minus alpha into phi x plus rx. Clear or not clear? Now what we are going to do is that we are going to apply alpha instead of x. So f alpha will be what? Alpha minus alpha into psi alpha plus r alpha. Correct or not?
Sir.
Clear or not clear?
Sir.
So that is r alpha, you can say it is a remainder. Correct or not? So then, so what we can write is that we can, we can write just r as a to represent as a remainder. So alpha minus alpha is what? 0. So what we get? If alpha equal to r, that implies r is equal to f
Yes.
of alpha. So that is why. Now you go back to this one. If the polynomial fx is divided by x minus alpha, the remainder is f alpha. That's what we have established it here. Let's take an example.
Yes.
Let's take an example. Then it will be very clearly understandable that why, how come we can conclude that one. Okay, let me take a different color pen. Suppose we have a polynomial expression equal to x square minus 3x plus 4 plus 4. Now what do you want to do? We want to divide this fx by x minus 2. Correct?
Yes. Sir.
So what is our task? Task is that find remainder when fx means what? That is x square minus 3x plus 4. Okay. So this is divided by x minus 2. Correct? That is our task. So one way what we can do is that we can do a long division. Correct or not? Okay.
Yes. Sir.
But another way of doing is that just find the value of f2. So what will be the answer? The answer will be, so this is a question, by the way. This is a question. So what will be the answer to this question? The quick answer should be the remainder is nothing but f2. That means 2 square minus 3 into 2 plus 4. Got it? So that is equal to 2. Correct or not? 2 square
Yes. Sir.
minus 3 into 2 plus 4 is equal to 2. That answer we give so quickly. But if we do not know this remainder theorem, then also we can able to give the answer. But for that, we need to make a long division. X minus 2 is here. Recall this long division, 3x plus 4. Correct or not? So what you will do here? You will write it here x, then you will get x square minus 2x. Correct or not?
Yes. Sir.
Then after that, what you will do? After that, we make this is plus, this is minus. So x square and minus x square got cancelled. So here we get minus x plus 4. Correct or not?
Yes. Sir.
So here we'll write, minus 1. So what we get here? Minus x plus 2. Then you put minus here, plus here. X got cancelled. 4 minus 2 is 2. So this 2 is the remainder. So that value we got by using, long division. But without division also we can find that value 2, correct or not? We got the
Yes,
same value
sir.
2 with a very less effort, correct or not? And that is
Yes,
the
sir.
advantage of having the remainder theorem. Okay, clear or not clear?
Yes, sir.
Okay. So now let's practice something. So here is the first question I'm going to give you. So we'll solve together. Okay. Did you get the question?
Yes, sir.
If 3x square minus 7x plus 11 is divided by x minus 2, then find the remainder. I want you to find the remainder. Hello, Bhumika. You able to do it?
Yes. Yes, sir.
Okay, I can help you. Shall I help you? Hello, Bhumika. Okay,
Yes, sir.
let me help you. No problem. No, never hesitate. So what is fx here? Fx is this.
Yes, sir.
So fx is equal to 3x square minus 7x plus 11. Okay. Now we need to find when this fx is divided by x minus 2, what is the remainder? So remainder is equal to nothing but f2. Okay, so that is equal to 3 into 2 square minus 7 into 2 plus 11. So that is equal to 12 minus 14 plus
Minus
11.
2.
Correct, na?
Yes, sir.
So that is equal to 9. Correct or not?
Yes, sir.
Okay. So it is so quickly we find it out. So what I'll suggest you, Bhumika, you know, um, once we are done with the, factorization, sorry, that, zeros of a polynomial, okay, that means that remainder, once we find the remainder, then only we'll able to go for the factorization. So I want you make little bit of practice, and then again we can have class if it is possible by you around 6:30, we can have a class. Is it fine?
Okay, sir.
Because we should spend more time in practicing, correct or not?
Yes, sir.
Okay, so I'm going to give you 2 questions. You please note it down. And then again we'll have a class around 6:30 so that we can make more practice. Got it or not?
Okay, sir.
Okay. So please join at the time also. Please write down these 2 questions. I want you give me answer to these 2 questions. Okay. Once we start our class at 6:30. Correct or not?
Yes, sir.
So please write it down. The first question here is that, if 5x cube minus 3x square plus 9 is divided by x plus 1, then find the remainder. And the second question is that, if 7x square minus 2x plus 3 is divided by 2x plus 1, then find the remainder.
Okay, sir.
Okay.
Yes,
Please,
sir.
do it, and then we'll have a class at 6:30. Fine?
Okay, sir.
All right. Thank you very much.
Thank you.
You take a note of these 2 questions, no?
Yes, sir.
Oh, all right.